Hello again, and welcome to this last chapter, which is about functions. So let me first just go over the outline. So we'll talk about the models, the C models, and then talk about blocks, the scope of identifiers. So whenever we talk about variables, whenever we are using a for loop, for example, and we are using a counter I, so we'll talk about the scope of these variables, and then we see how can we declare, how can we define a function, and how can we return results using functions. And then we will talk about parameters, and then we will just go over quickly about recursive functions. So let's start. So as for the introduction, so we already used a lot of functions. So we have used, for example, printf from standard input output, the string length, the str len from string.h, and power from math.h. So the functions are so they are subprograms, a small code which we call functions that are embedded in C. We call functions, so we can write our own functions and we can distribute them and let others use them. So for example, here I have some start patterns. So as you can see, I have some repetitions. For example, I have here a square. A square is composed of multiple lines, for example 4 lines, and in each line there's 4 stars. So I can write, for example, a function that prints just one line of x stars. So this is an idea. So here I'm printing 4 lines of stars, or I'm printing 4 lines of stars, and each line, it contains the number of its lines. So we can see it like that. So we can decompose the problem into a smaller sub problems and reuse some previously written functions. So this is the modality of a program. So we use a predefined functions and we use pre-written functions. So we have already used the main function. So and we have wrote it like this: int main and brackets, and there's nothing here. So int here, it's the return value. So this is the function, what it returns. Usually we placed a return 0 at the end to say that our function, it returns the integer 0. However, in some cases that we will see later, it could return float, double, and some other stuff. Again, we will see some variables here which we call the parameters. So in main there is no parameters. However, in the second year maybe you will see about the preprocessor, and you can see that in main, yes, there is some variables, and you will see it more in Java. So in main there is no parameters. However, we can add parameters, and we will talk about it later. So if we have a very big problem that we have like thousands and thousands of instructions and variables, so we will not write it just in one main program. So it's better to decompose it and then just call these functions, because if there's an error, if there's a mistake, I can spot the mistake and correct it. However, if I have just one main function and there's a lot of instruction, it will be very difficult for me to debug this code. So in most of the programming languages, not just C, they allow to use models or functions or subroutines. So we use that because it's more efficient and it's more elegant. So efficient because I can debug and I can reuse those functions. So we'll see in a while. For example, for the array, so I can write a function to read the array. I can write a function to print the array. I can reuse it every time I'm dealing with array. There is no need every time to read the dimension, to write the code and stuff like that. So I write it one time and then I will reuse it. So like we have done with the power function, like we have done with printf, we didn't write printf, we just used the function printf and scanf. So what's the advantages of doing that? So it's more readable, it's better readable. So of course, because when I'm seeing a smaller program, it will be easier to understand. Imagine that I'm placing the code of power every time I'm calculating x power 2. So it will be very big, it will be unreadable, and if I have a mistake like a missing bracket, I will not find it. So this is it. I will reduce the risk of errors, and I can do more tests and more targeted tests. So when we use a model, so we can know its effect because we are just dealing with this model. So we know what's the input and what's the output, and we see how can be used. So we can reuse it, of course. We every time use scanf and printf, and we can write our own functions and reuse it and give them to other people to use them. And it's very easy to maintenance because I can change, replace some of the code, and I can know if it will affect or it does not affect the other programs or the main program. So again, we have the fostering teamwork. So if there's a team that's working on a big project, so each team, so each member of the team can work on a separate function, and then we will combine all these and come up with the final main function. So we have a hierarchy of models, so we'll talk about that in a while. So we can either, for example, first define the set of functions that we are using and then write the main function, or we can start with the main, telling, okay, I'll be writing this function, and then I'll be writing this function, and then I'll write this function. So we have two types, either a top-down development or a bottom-up development. So we'll cover that later in a while. So let's take an example and see the advantages and how we can think about using function and decomposing a problem into a set of functions. So the problem is here is I want to display a rectangle of stars. So we have H line and L is the number of stars per row. So if I want to write it normally, so I need to define two variables, L and H. So I need to enter the length, I need to enter the height, and then I will do two for loops in order to do this stuff. However, I can use or I can write a function called the rectangle. So the rectangle, so pay attention here. As we have said, there's parameter in between the brackets and there's a return value. So here I have chosen to place main into void. So the return value is void. There is no return 0 at the end. If I want to place int, there's a return 0 at the end. So I have introduced void here to say void. It means that there's no return value. So it means that, like in power, so a power, it's prototype. We call it prototype. Float A, float B. It could be also double power, double A, and double B. It means that if I have a variable x of type double, I can write pow x y. So it should match. So those functions should match. This is what's inside the math.h, and this is how I call it. So I call it with equality here because it returns a value of type double. If my function is of type void, there is no equal. It doesn't return a value. It doesn't do calculation and return something to me. This is the case of rectangle. Rectangle doesn't have a return value, so there is no equal before it. There's no equal. I'm not assigning the value like power to the variable of x. So it's a void function like main here. So it takes our main, it doesn't take any parameter, there's nothing here. However, our rectangle function, it takes two parameters, it takes two variables, it takes two values of the variable. So in rectangle, I will pass the value of L and the value of H. So I will not give them the variable, the memory. I'm just giving them the value of L of H, for example, 4 and 5. So here in this program, like we have used scanf printf, we have included standard input output. Why? Because whenever the program sees printf, it needs its code. So I'm telling, before encountering the instruction of printf, I told the compiler that make sure to use the standard input output. However, the compiler, when it sees that you are using a function called rectangle, and from the starting of the program till encountering the rectangle instruction, you didn't tell him that you will be using rectangle. So for that, we need to give them the prototype. So this is the top down. So I'm telling that, okay, later on I will be I'll be writing the code of rectangle. It will take two parameters, L and M, L or H, it doesn't care. You can omit these variables, we'll see it in a while. So it takes two parameters and it doesn't return anything, it returns void. So this is very important to say that if I'm doing that, I should just tell the compiler that I'll be writing it later on. Another way is to declare or write all the function before void main, before calling the void main. So let me erase. So we will repeat all this while we are going with the lecture. So don't worry, I will always repeating the same stuff in order to get it and grasp it in your head. So we have here, there's just one more notion, is that we have here two variables, integer L and integer H. So whenever we are dealing with functions, as we're just starting dealing with functions, whenever we see a variable inside a function, we call it a local variable. So L and H are local variables to the function main. So let me repeat quickly. So we have the function main. So our main here is of type void, so it's on purpose. So if you want it int, you should return a 0 at the end. So whenever a function returns something, I should have a return instruction. So if there's int here, there should be at least one return somewhere in the code. We will see it later. So void, it means that it returns nothing, like our function rectangle here. So the rectangle, the compiler, it needs to know that you will be using a rectangle function, not just directly. He should be prepared. So I'm telling you here before that, okay, I'll be writing this function later on. Another way is to write the function, all the code of the function, before writing the main function. So as if we are doing the printf and scanf, they are already written in the standard input output, the header file. So we have the function rectangle. So the rectangle here, it takes two parameters, two variables. So here it takes the value of L and the value of H. Now let's write the function rectangle. So our rectangle, it has two parameters, two variables, L and H. Those are the input to the function, and the output is nothing. So what does it mean output is nothing? It means that it doesn't return value to its callee. So the caller here, the callee, the rectangle, it calls the function rectangle on the next page. However, there is nothing, there is no equal here, that it doesn't return anything. However, whenever we have void, it's a general rule, mostly we have printf. So we need to do some printing on the screen, because printf doesn't return. We don't care about what the printf returns. It's most probably it's a printing. So to print the rectangle, I'll be using another function called line. So I will be printing h line. So I'll be looping h time, and I'll be printing a line of L stars. So again here I'm using a function line. Line, it takes one parameter, the value of L, and it doesn't return anything, so it's of type void. So again, if I'm using the same scheme, so I need to tell the instructor, the compiler, sorry, that I will be writing the function line later on in the code. Again, I here is a local variable to the function rectangle. So just pay attention to the fact that every function has its own variables. So just pay attention that in main I have used L and H, and in rectangle I have also L and H. The L and H in main are different than the L and H in rectangle. So each function has its own variables. Even if they have the same name, they are different. They are local. We are called local to this function. So in main, I have two local variables, L and H, and in rectangle, I have three local variables. I have I have L, and I have H. So this is it. Now let's move to line. So line, again, it takes one parameter, the value. Remember, it's always the value, not the placement in the memory, the address in the memory, or anything in the memory. It's the value. We are copying the value of L. So for example, here I'm printing 5 stars, if those are equal to 5. So line L, it takes one parameter L, and it returns a void. It doesn't return anything. So look well. So I have called it here L. So you can call it A, you can call it B. Who cares? It's a local variable to the line. It's just visible. It just we can deal it within the function line. So I need to print L star. So I'm looping L times, and I'm printing a star. Again here, look well. I have two local variables, which are I and L, and at the end I will be printing \n because I need to go to a new line. So let's see how we have proceeded. So in main, we have two local variables, which are L and H, and we have called the function rectangle that takes the value of L and the value of H. In rectangle, it has three local variables, L, H, and I, and we have called the function line L. And line L, as a function, it takes the value of a variable L and it has two local variables L and I, and it doesn't call any other function. So we are dealing here just with the user written functions. Of course, we're not talking about printf, scanf, power. Those are the predefined functions. So I will be, before moving to example 2, I'll be doing what's called a memory state. So I'll be erasing all these and do the memory state. So in memory state, it will be covered in length at the second year. However, it's very nice to see how we can work with memory state. So in memory state, it means that what will happen in the memory. So in terms of 0 and 1s, how can a program be executed, and we have multiple programs. So you should know that every program should have a main function. If you don't have a main function, it will not execute. So it's very important to have one and only one main function. So every program, it starts from main and it ends in main. So for example, I will start from here and I will end here. So even if I have 1000 functions, if I'm not calling these functions from this main, they will not be executed, and the execution starts from main. So in main I will start line by line. I have two variables L and H. So in the memory, so I don't have an empty space, so I just erase this. So I will copy and see what we will do. So we have in memory state, so we have said that everything starts from main. So this is the function main. In main, I have two variables, L and H. So I'm working line by line. And then I have a printf and a scanf. So a scanf, I need to enter a value in L. So let's say I will print 2 stars by 4. So I will have this part. I don't want to make it big. So L would be equal to 2. So I place 2 in L, and in H I will scanf 4. And then I will call the function rectangle. So whenever I'm calling function rectangle, so rectangle is not in main, it means that I will stop executing now main. I will make it on hold, pause a bit, relax, and then I will be doing rectangle. So main cannot proceed unless rectangle finishes. So now this one is on hold, pause, stay a bit, and we will move into rectangle. So to rectangle, I am passing two variables L and H. So I will just remove this code and move and copy the rectangle code and see the execution. So now in rectangle, it has three local variables. It has I, L, and H. So we know that when I'm calling the function rectangle from main, the value of L was passed to the variable L, and the value of H was passed to the value of H. So look well, there is 2L and 2H now. However, I'm dealing now with rectangle. The main part here is on hold. So I need to execute the code. So I have the variable I. In I first I have placed 0. And then for I equal to 0, I less than H, okay, 0 is less than 4, I will execute line of L. So line of L is another function. So now I cannot execute rectangle because I should execute another function of this line. So, okay, this one is on hold now. Look well. So it cannot proceed because I need line. So line, the rectangle, it will pass the value of L. The value of L now is equal to 2. So line, I will we have made a mistake, so we should have kept the elements. So in line, I will copy this and just move this a bit. So we had the rectangle, it has I, L, H, and we have I equal to 0, and then we need to call the function line. Line of L. So in the function line, we have two local variables. We have I also, which is different than the I in the rectangle, and we have L, which is different than the L of the rectangle and of the main function. So we are passing the value of L. So the value of L is equal to 2. We have 2 here. So let's execute now line. So I can execute it for I equal to 0. I place 0 in I less than L, okay, 0 is less than 2, I will print 1 star. So for now, I'm printing on the screen, so this is the screen, 1 star. I will increment I plus plus 1, 1 is less than 2, I will print 1 star. And then I will increment I, 2, 2 is not less than 2, it finishes, I will print just backslash n, so I'm moving to this line now. Now, what happens? So I have finished line. What does it mean I have finished line? So in the memory, this function will evaporate. It will be erased. It will not exist. It will be deleted. So nothing will exist. So whenever I finish line, now I can proceed with a rectangle. So I'm here now. I'm here. Where here? I'm here. I have finished executing line of L for the instruction where I equal to 0. Now I can continue. I will increment I. So now I is equal to 1. I'll check. 1 is less than 2. I can execute line of L. Again, so I cannot continue with rectangle. I need to execute line. And a line, I have two variables, I and L. L is equal to 2 and I is equal to 0. So we'll be repeating the same stuff. You've understood that. Again, line will finish it and we will move to rectangle again. Now a rectangle, I will increment I, 2 is less than 4. I will do another call for the function line. I will start from 0 and L is equal to 2 and again I will print 2 stars. After printing 2 stars, line finishes and I can continue in rectangle. In rectangle, now I is equal to 3, 3 is less than 4, and yes, I can call the function line with I equal to 0, L is equal to 2, and I can print 2 stars and go to a new line. So after printing this 2 and the line function finishes, it will be deleted, and then I will be back to rectangle. I will be incrementing I, so now I is equal to 4, 4 is not less than 4, and now I'm out of the for loop. There's nothing to execute. The function rectangle finishes and it will be deleted from the stack, from the memory. Now I can proceed with the function main. So if you remember, in main, the last instruction was rectangle. Now I have executed, I have finished executing the rectangle. So I have finished executing the main. And whenever we finish executing the main again, so the program finishes, and at the screen we will see this pattern. So this is the memory state. It's very important to at least run some programs because it's very important to see how it will work. You will do that at the second year a lot, and it's very interesting to see how we have the variables. So you can see here there's multiple calls of line. So don't be mistaken that we have or just one function, one call of the function line. We have called line 4 times. At each time we have 2 new variables I and L, which are different than the I and L in main and in rectangle. So this is the idea. I hope that you understood it, and let's continue with the example 2. So in example 2 we will be dealing with arrays, so functions with arrays. So we have here a mathematical numerical function which is defined by the following formula: x cubed minus 2x plus 1, and we want to build an array. So we have 2 arrays that contains x, and the another array that contains the value of x using this function. So they are showing us the output, so we should ask for the number of elements. So there should be between 1 and 100. So this is the dimension of the array. We already done that, so we just need to embed these do while reading of the dimension into a function, and then we need to write a function also to read the input, the array, and then we need to calculate the output of this function and then display. So we can write it all in just one main function. However, here we have the chance to write it using multiple functions. So we can write a function to read the dimension, we can write a function to read the array, we can write a function to calculate f of x, we can calculate a function to calculate the values of each element of the array, and we can write a function to display an array. So we can write 6 functions to solve this exercise. So let's start. So again here, let's see how it will work. So we have two arrays. X is the input, so those the values that the user would enter. Float v, those are the output. It contains the value of f of x. We will write at least 4, however we will write more. So we have acquire, so this is the reading of the dimension. So let's break it down. So it doesn't have any parameter, it's like main. So it doesn't need anything. So if I want to read the dimension, I will not give him anything. Maybe I will give him 100 or the size. I will define it as a global constant. It's not a big deal. Or you can pass it here and it will return the size of the dimension. There's a return value because it will give me the example here, the number 9, because I will be using it to print and to calculate the functions. So, and then I need to, I wrote a function called the read array. It takes the array x. We will talk later on how to call a function with arrays and the actual dimension. So I'm telling here, I'm writing a function that reads n elements, n where the effective size of the array. And then we are calculating the value. We have x, which is the input. I've already filled it with the function read array. N is the dimension, and v here is the output. So you are tempted here to say v equal calculate values of x n. However, we will not explain it here. In arrays, especially, we'll see it at the next year. It's considered as input output and we cannot place it as equal. So we already talked about it while dealing with strings. I cannot place equal because the name of the array is constant, so I cannot say that. So I will be placing it in the parameter and it's considered as an input and output parameter. So I can fill it even if it's an input. So you will understand it and explain about it more at the second year. However, as a convention for this lecture, for this course, for this part, is to place the arrays all in the parameter. We don't have an array as a return value. And then I need to display, so those are input now because v now was filled and have a function called display array. It takes x and v and as input and n as dimension, and I will display both x and v. So as you can see, those three functions, it doesn't return anything because they will be calling each others or some other functions, and there will be just printf. So let's write each of these functions. So here we are telling that, okay, what's the difference between a void and not void? So in other languages or other programming languages, we call a procedure. It doesn't return anything, it returns void, and usually a void is used to print something. Or I'm calling other functions. So functions, we will see it later again, that either will be added above or below the main. So we have already also shown that we are using prototype. So for example, we have already told you that this is the prototype, just to tell the compiler that I'll be writing later on the function. So let's try to solve this exercise. So I have here reused the main with n to say that it has a return value, just to pay attention and to be sure that whenever you are seeing a function that has other thing than void, there should be a return here. So I'm just pointing it down to not forget it. So since we are using a main, so I'm using here 4 functions. So I should tell the compiler, please make sure that you will be using that. Later on I'll be writing these functions. So let's spend some time on how to write the prototype. So usually prototype, you can copy paste the declaration of the function. So it's the same. So you can write int acquire. So here it takes an array and n. So I'm declaring it's an array and n. And look well, it doesn't need to have the same variable. So here I'm declaring it as t. However, here it's called x. So, and also you can omit the name of the variable. So for example, void read array, you can write it like this: void read array. You can say float array and int. So because in the prototype we don't care about the variables, the name of the variable. We just need to know that, okay, the first parameter is an array, the second parameter is an integer. There's no need to know the variables because it will not be allocated in the main, and whenever, as we have seen in the memory state, there will be other variables local variables for each of these functions. So to acquire in the function acquire, there's no inputs. However, we have an output, which is the actual size. So it has just one local variables, and we're doing a do while, and we're just reading the actual dimension. So there's an address here, it's misses. So and we return and at the end. So whenever we have anything besides void, there should be a return. So I'm returning an integer. So there should be a declaration of an integer type. I cannot declare float and return an as an integer. Those should match. I have value here should be of type int. So if I'm returning an, it should be of type int. I can return 2. Okay, 2 is an integer. We can know that. But how we should pay attention to this. To read an array, so as I have told you, an array is an input output. So I can either consider it as already filled, or I can fill it. And read array, I'm filling the array. So I'm just looping n times because I need the actual size, and I'm filling the array. There is no return because the arrays are considered as input output. For calculating the value, so I have the first parameter, which is the array, which is already filled, which is input. Float v is the output array. It contains the value of the functions, and n is the dimension because I need to loop. So I'm looping from I equal to 0 to n, and I'm placing in v of I in the output the value of x of I. So I wrote a function called f, which calculates the x cubed minus 2x plus 1. So again, since I'm writing it later on in the code, and here he encountered f of x, so I should give him the prototype that, okay, later on you will see a function of type float. This is the type float. It's called f, and it takes one parameter of type float. So this is for the calculation. For the display, I'm having two input arrays with the n. I'm just looping 2 times from I equals 0 to n, and I'm displaying the first time x of I and the second time v of I. So as you have seen, so we have 6 functions, so which 3 of them does not provide any result. So, and as I have told you, if I have a function f and it has a returned value of type float, we say that f is of type float, or f has type float. And again, remember well, if a function has a returned value, it should have a return command, it should have a return instructions. You've already used it in int main. At the end you have a return 0, and whenever you have a function that returns something, there should be a return. It returns the value. It returns the value of something. So what about, so here we are talking about the arrays. You should just pay attention that whenever we are dealing with arrays and whenever we are calling an array, so later on you will see at the second year the operator address in functions. Will not cover it in this year. However, with arrays we just call the array within the parameter, not in the return value. So this is was an introduction. So let's move now to more subtle parts, which are the notion of blocks and the scope of identifiers. So as we have told you, in each functions we have local variables. They are local to this function, so we consider a block. So a block is defined between curly braces. So, and we can have also in between curly braces local declarations, local variables. So for example, in a for loop, I have curly braces. I can declare a variable x, and x is local to this block. We'll see it in a while. So as I have told you, so if I have curly braces, so this is a block, I can have a local variable to the block. It means that I is only, so this variable I is only visible here, we can deal with it here. I can have other I in the program, I can have other I in the function, so it's a bit tricky. So we are having here an example. We have a function f. I have the variable x, which is once it's an integer and it contains 100, and a second one times it contains x. So I have here curly braces, and I have here 2 curly braces. So I have here double x, and I have here int x. So the x here is only visible here, and the x here is only visible here. So if I'm doing x equal x multiple a equal to a, it means I'm using this x and in this part I'm using this axe. So and there's, if I'm here, I cannot access the axe which is in the outside block. So we will be approaching to what's called global variables. So we'll just wait a bit. So let's there's a convention here, and it's very important to not do this stuff even if it works. Usually in C and NCC, as we are doing, we always declare the variables at the start of the function, as we have done in main. As I have always solved these exercises, I've always paid attention to declare all my variables at the start of the function of the program, not whenever I want to do that. So in other programming languages or some other instructors, they tell, for example, their students to, whenever you are using a variable, you can just declare it and use it. I'm not into that programming style. So every time you want to declare a variable, make sure to declare it at the top of the program, so that you know what are the variables you are using, what you are missing, and stuff like that. So we will move to global variables. So as we have seen, we have already used global variables whenever we have used the command define, for example, define size 100, and we have used the variable size whenever we want it in the program. So this is called a global variable because everyone can see it. In any functions we can use the variable size. So usually the global variables are declared at the beginning of the program, not in main but outside the program, like in define, and it's used everywhere. So just an example here, I have the variable status. So it's a global variable, it's not a constant because it could be modified. We have here the void A and void B. We have two functions that are using the status. One is decrementing status and one is incrementing status. So it's possible to use that. However, it's recommended to not use global variables, because whenever you are using global variables, you will not be able to track any mistake. Even if, for example, you are debugging and you've noticed that there's some wrong values, you will not be able, because there's more and more functions, many functions that can be modifying this variable. So for me, and as an advice, please do not use any global variables. Just stick with the define, because whenever you do define size 100, even if it's a global variable, it's a constant, because we cannot modify size. It's constant here. No one can modify the value of size unless you modify by yourself and you say, for example, size is equal to 1000, but you cannot write in the program size plus equal to 10. It will give you an error because you cannot modify a constant. So let's move now to how we can declare and how we can define the function. So if you have followed me, it will be very easy for you now because you've already grasped all the ideas. However, we will move on each part. So we will see how we can name. So the name of function should appear in 3 places in the program: during the declaration, and when defining it, and during the call. So during the call, it means whenever I'm calling. For example, I'm calling rectangle, and whenever I'm defining it, it means whenever I'm coding it, I'm writing the code, and declaration is the prototype. So we can see that we can omit some of these, so just wait a bit. So we have here the declaration and definition of a function. We have a function main, and as you can see, I have wrote the input and max function later on. So I'm obliged to write the prototype, because whenever the program reaches here, he sees input, he sees max, and there's nothing. He doesn't know that later on there's an input out maximum, so I should have the prototype. So here we have a function input that takes one integer, so it's very easy. So there's a scanf, so there's no input here, and there's one return value, which is the value that is entered by the user. It's just an integer. So we have int, we have a return number here, and number is an integer and is read using a keyboard. And then we have the function max, which returns the maximum between two numbers, and 1 and 2. So let's just pay some attention to the max. So it takes two integer and 1 and 2. So if I want to check the maximum, so I just need to make a comparison. So if n1 is greater than n2, I should return the value of n1, otherwise I should return the value of n2. You should pay attention that whenever I see a return, or I execute the instruction return, the function ends. So if n1 is greater than n2, I will return n1. So I will not execute anything else, even if there's some other instruction there. Whenever the instruction return execute, there is no need to do a return. So You can write this like this. So if n1 is greater than n2, return n1. There's no need for else here. You can directly place return n2, because if we execute return n1, we will not execute anything else. If we don't execute return 1, so if the f fails, I will return n2 directly. So you will notice that, and you can work on your skills as long as we go with this chapter. So to define a function, whenever I'm defining a function, I need a name. For example, a rectangle, line. So the name, it should match the specification that we have already shown in the previous exercises, like the variable. So a function doesn't start with a number. It can start with an underscore, with capital letter, small letter, but never with a number or a special character. So it has a type. So the type, this is the type. So it's the return type. It could be void, int, float, double, or anything other that you will discover in the second year. And it should have a parameter. So the parameters, they have a name and they have a type. So and if we need some local variables, and of course the instructions and the statements that should be executed. So okay, the identifiers, we already talked about them. So there are we know the restrictions. And pay attention that, for example, you can write your own function power. However, if you are including math.h, it will be overwritten. So make sure to just rename it. So in some compilers, like the one we are using online, some of these compilers, they allow us to redefine functions, already written functions. Others, they told us, they will give us an error. Okay, please, this function is already defined. Make sure to change its name or write another one. So we have already talked about the type. So here we have definition of maximum. So we have already talked about it. We have here a function float pi. So pi, look well. So it's like main. It doesn't have any parameter. So you can either say void, write the word void, or you can keep it empty and it returns a float, a number. So whenever we are calling pi, we call just pi, and we have equal because it returns a value. For example, float x equal to pi. So let's move. We have some remarks. So a function can provide a result in arithmetic type, int, float, double. It could be void, like our printing functions, or the one that we have done earlier. So a function cannot return arrays, strings, or functions. So this is very important. So a function doesn't return arrays or string or function. So we can return a pointer to an array or character string. We see that in the second year. For now, for our case, we just pass arrays and strings and as parameters, and they are considered as input and output. So I can declare an array outside in main and then pass it as parameter, and it will be filled by the function. So if a function doesn't return any value, we should write void. We cannot keep a function without a type. So this is very important. So if a function doesn't have a parameter, we can keep it empty here, or we can write the word void in between the brackets. So, and one important remark also is that we are not allowed to define a function inside a function. We should write functions on separate blocks. So whenever in C, so if you want to use a function, we should declare it before that. So just we inform the compiler that, okay, we are using this function and it will have this number of parameters and this type, this return type, because it needs to verify that they're matching and you are writing correctly. So it just it's helping you to not making any mistake. So it controls the type, the number, and if the parameters are correct. So here is the remark, and this is what I always do, is that if the program text, the function is defined before it's first called, it doesn't need to be declared. So usually what I do is that I don't code like this. So what I do that is I write input and max before main. So whenever I'm writing that, there's no need to do the prototype, because whenever it reaches main, he already passed over input and max, and there's no need to tell the compiler, okay, I'll be using that, because he already know the code, he already knows the input, the prototype and the type of the function, so there's no need to tell him again, look, well, there's functions I'll be using. So this is how I'll use. However, we will see in a while that there's other schemes too. So whenever we are doing the prototype, so as I have told you, there is no need to place the variable name. So this is valid and this is valid. This is what I have already seen. However, you can omit the variable name because there is no need to say the variable name. As I have told you, the local variables, they have the same name. It doesn't, it's not that important because each function has its own local variables. So whenever we are declaring, we are giving the prototype, the number of parameters should match and the type should match. So the name is not important, so they are not considered, they are disregarded by the compiler. However, it's for you. It's maybe you will do it, you will consider it for yourself to keep track of the calling. So usually what we will do, if you want to follow that scheme, you do a copy paste for the prototype of the function and you will work with that. And do not forget that there's always at the end of prototype a semicolon, not like the code. So let me go back. So here int input, there's no semicolon. However, when I'm calling its prototype, there's a semicolon. So whenever I'm declaring, it's like main, there's no semicolon here. However, for the prototype, there's a semicolon because it's an instruction in the code. So to declare, what are the rules for declaration of the functions? So again, we can declare a function either locally or globally. So we will consider some rules. So usually a function, it can be declared locally. So it's visible just in this function. Otherwise, we can use it globally. It's written at the beginning of the program, so just after the include statement, so it's available for all the other functions like we will be doing. So usually we'll be doing a global declaration. We have the implicit statement by the definition. So whenever we are writing a function, it will be automatically available to all other functions. And we have multiple declaration. So a function can be declared multiple times in the text of a program, but the indications must match. For example, I can write multiple prototypes, the same prototypes in multiple functions. However, I should define it just one more time. And one rule, main, it doesn't need to be declared because every program should start from main and should end from main. So we will consider this hierarchy. So we have a function main, it will call fa, and then it will call fb. So we'll see a three variant of this logic, how we will be doing. So the first one, so here you have the text, I will explain it directly on the example. We have the local declaration of functions and a top-down definition. So this is what we already done. I begin by writing the main, and since I'll be using fa, I'll just put the prototype inside main. So you should be sure that fa, it will be used later on. Then I have fa, it will be using fb. So fb, I should place the prototype in fa in order to use fb. So this is the top down with a local declaration of function. The bottom up without declaration, which I always use, and this is what I'll be using while solving the exercises, is that I will write fa and fb before main. So in main, I'm calling fa, I have fa. And then if I have fb, I should have already written fb before fa. So I cannot write fa and then fb, because in fa I should have fb and I should have already encountered fb. So the third one is the global declaration of function and a top-down definition. So in global declaration, I don't have the prototype inside the main, but they are outside the main. They are considered global, and I have the same declaration. However, I have omitted the prototype of fa here, and I have omitted the prototype of fb here. So you can use any of this scheme. However, for me, as I have told you, I'll be using the bottom-up definition. So there's no need to copy the prototype. There's no need to write the prototype, and it's more easier. And always I'll be keeping main at the end. So as a conclusion for this part, not a conclusion for the course, for this lecture, so we'll be using a top-down definition in this lecture. However, in solution, I'll be using the bottom-up. that reflects the structure. So we have many dependencies, so we'll be declaring the functions locally, so inside the functions. So we have here an exercise. So we consider the main, pi, and area, the functions defined by the following program. So establish the call hierarchy for the three functions. So tell us how the functions are related. So we have always, we start from main. So in main, I'm calling the function area. So this is area. In area, I'm calling the function pi, and this is the functions and the calling that happens. Define the functions according to the three methods by adding the missing declaration. So we're doing the top-down, either with the local or global declaration, or the bottom-up. So here we have the main at the top, and then the function. So we will have a top-down. So we need to declare the functions. So if I'll keep the same code, so as you can see, I have pi here. So there's no need to place the prototype here because it's already encountered. However, for main, I need to place the prototype of area. So I just need to copy. I will say double area and double. I can place radius, or I can skip any don't place the name of the variable and say semicolon. So this is top down with local variables. If I want to do it with global variables, with global definitions, I place double area above. And if you want, you can place also a pi as a prototype. For the bottom up, you should place both functions before main. So in C, what messages does the compiler provide when a function is not defined or declared before it's called? How can these messages be explained? So you will see later. So we'll give you an example how. So it depends on the compiler what's the error, but usually it will tell you that the function is not defined, even if you are defining it later on. So for example, if you keep this code and compiling it, so without placing the prototype, whenever it reaches area, it will tell you area is not defined. So the returning of a result. So again, let me remind you that every function should return a value and should have a return type. It should have a type, so either a void or a numerical value, and we should say void. So if it returns a result, there should be a return instruction. It returns a value. It returns something. So the return has the following effect. So it evaluates the expression. So for example, if I'm return 2 multiple x, it will evaluate 2 multiple x. So if x contains 1, it will return 2. If it contains 0, it will return 0. It evaluates. It means it evaluates the expression first, and then it will return the value. And also there's an automatic conversion. So if x is an integer and the function type is float, it will promote 2 multiple x, which is 2, to 2.0 because it's of type float. It returns the result, and the function will terminate. It will be erased from the memory. So to return a result, so we have the square function. So it takes one parameter x, which is double, and it returns a double. So it's called double. So we just calculate x multiple x, and we return the value. So how can we define ourselves a function tangent, which calculates the tangent of a x using the function sine and cosine? So this is a small exercise. So you know that tangent is equal to sine over a cosine. So of course, if I want to do division, I should be sure that cosine should be different than 0. However, so I can call this function. So it takes one variable x, and it should return a double. So we can call the square of f, which is x, is equal to square x, and the tangent is tangent of x, and I know that the cotangent is equal to 1 over tangent of x. However, before going to this node, I have here a small problem. Is that suppose that in the main I have I'm calling, or I'm writing y equal tangent of x, and suppose that I have in x equal to 1. So cosine of 1 is equal to 0. So I'm not executing the return. However, I'm just printing on the screen error. So I'm seeing on the screen error. and then I'm going to the line, and then I need a value, and then I'm dealing with y. For example, I'm saying y plus plus. So in y, there is nothing. I didn't return a value here. There is something wrong, because if I have a double, there should be a return. Even if I'm not executing this part and I've executed printf, there should be a return. There's something wrong in this function. So just pay attention that whenever I'm using double, I'm using a return value. So there's an equal here, or there's a printf like here, and maybe I'll be using y. So this is here the advanced note. So you should pay attention to the result of an action, of such an action is unpredictable. So whenever we have a function that has a return value and we don't use a return, the returning value is unpredictable. Because what does it mean? X equal tangent of x. It means that the function should return a number, should return a double. If I don't return a double, the function, the compiler will give y any random value to y. It's unpredictable. It will return any random value. So for that, you should be sure about what's returning. So for that, we are still in the advanced node. So we have a double here. So whenever if its cosine is different than 0, I will calculate the tangent. However, if it's not, I will do the printf and then I will end the code. It's not just I'm returning a value. So okay, I will not return any value, because the program will not continue. I will just exit. It's in the function in the header file standard library as the lib, and it takes an error code. So usually it's equal to -1. Whenever we encounter exit -1, the program terminates here. It doesn't need to finish in main, as I have told you. Every program starts in main and ends in main. So whenever they are exit, it means that stop the execution of the program. There's a problem here and you cannot continue. So the idea here is not that you will be using exit every time you see that. Just pay attention to the fact that whenever you have a return value, make sure, and if you have if, else, you have multiple conditions, make sure that there is always one return instruction is executed. You will see that in some of the compilers, so especially the ones for competitions and online compilers, they force you to use, they should see a return value. If they don't see a return value, they'll tell you, okay, you are doing a problem, there's a mistake here, and they will not allow you to compile your program. So it's very common to see that, and some compilers are very strict. They want to see a return value on a separate line, not inside if and else. So this is not acceptable. They will tell you, okay, if you have a block, if you have function, there should be a return value on a separate line, because they will be sure that a value is returned. So this is the advanced node. So we should just pay attention, because it's not obvious at the first. And sometimes we ignore the result, even if the function returns a result, like scanf and printf. We already done that. So printf returns the number of printed variables. Scanf, it returns the number of correctly read variables. So usually in those functions we ignore the result, and again also in our cases we can ignore the results. So the parameters of a function, so they are considered as a mailbox. They are the input, so they are what the function needs in order to operate. So the parameters are simply local variables also, as we have seen, like in the rectangle and h, and they are initialized by the obtained value. They are passed by a copy. As we have seen also, we have the automatic conversions between the calling. So we know that the prototype of the function power, it takes 2 double and returns 1 double. So if we have a and b are of type integer, so we know that power, it takes double and returns a double. So b would be promoted to double. So the value of b would be promoted to double. 2 will be converted to double. It's equal to 2.0. And then the value of power is of type double, and then it will be converted to integer. So we have here multiple conversions, so it's not that difficult. So for the first year, all the parameters, all the values that we are passing are by value. What does it mean by value? It means that we are photocopying it. I have a variable, it contains L, it contains 2, and I have a function that has a parameter which is L. I will not be using the same L, I will be copying the value of L into the variable of the local functions. So this is by value. We are always copying the value. We are not using the same variables. So the as we have seen, so this is the example of the rectangle of star and the star. So we have here a triangle is formed of multiple stars. So we have the function stars that takes one parameter, the value of L. However, here we have N. So N, it takes the value of L, and N is different than L. So this is how the calls work. So we already done the memory state. However, here it's more succinct in terms of schematically drawing it. So I'm starting with triangle. So triangle, it has an L. For L equal to 1 to 10, I'm doing star plus plus. So this is the value of L. For L equal to 1, I will go to stars. So N would contain 1 because L contains 1. And as long as N is greater than 1, I will print 1 star and do minus minus. So N is equal to 1. And then I will do print f1 star and then 0. And then I will finish a star and go back to triangle. So I already done that. They are doing it in vertical scheme. So the advantages of using passing by value, it means that, look here, and I can use it as a variable, as a counter also, and can modify it, and it's very useful. So we'll be solving some of the exercises like this, where we don't need to use, for example, a for loop I here, another variable. So I'm just minimizing number of variables, and I'm using n also. So as the passing the address of a variable, so there's another way, is that I can pass a variable, not a copy of it. So I'm not copying L. I can use the same L which is in the main. This is a very advanced technique, and it will be covered next year. So passing the address of one-dimensional array. So again here, while dealing the array, I have told you we cannot return an array. We can not return a string. However, we can pass the name of the array. We just need to place the name in between brackets. So here's an example. I have here wrote the function to strlen, the one that we have used. So it needs an array of characters, and it returns the number of elements. So we loop for n equal to 0 till we reach \0 as plus plus, and just incrementing the number and plus plus, and whenever I reach \0 I just return n. So I just need to call the function that just the parameter is just an integer, the array of character. And if I want to call the function, I will say int x strlen of str, for example, and str is of course is an array of characters. So look, well, I'm just giving it the name of the array, not the array with the brackets and all this stuff. However, when declaring the function, I should say that it's an array. So as a practical remarks, so if you want the function to work with a non-strings, non-characters, so we know that here that the ending of a string is always \0. However, if it's an array, we don't know when it ends. So for that, we should always give the functions the number of elements in this array. So we already seen that. However, whenever we are reading an array, we need the actual size, because we already read n using another functions. So we already see that. So let's see what happens here. So we have the main function. Though the main function, we have the prototype here of the reading of an array. We have an array integer t. So look, well, whenever I'm doing that, I'm always declaring an array before that, because it's an output. I should fill it. So it's in the main, so I can use it later on with other functions. So we have n, the number of elements, and p tab is the array. So I'm looping here n times. So look, well, I have used n, and n is decremented till we reach 0. We have di for the index of the p tab. So let's see how it will work. So we have here 4, so we need to fill just 4 elements. So whenever we are calling read array, n 4 would be in n, and t, it will point to p tab. So in n I have 4. I'm looping, so as long as n different than 0, so n different than 0, I'll do scanf. Scanf, I will enter 5, and I will place it in index of 0. So look, well, I is equal to 0, and then I will increment I, and I will decrement n. Now n is equal to 3. 3 is different than 0. I will be reading 6, and so on. So I'll be adding 5, 6, 7, 8, and at the end, look, well, I'm here. So 4, it remains 4, and the array t will be filled by the element of 5, 6, 7, 8. So in the next year, you will see how it will work that for the arrays, because here it's passed by, this is not by copy, we're not copying the T and P tab, we don't have two copies of the array, there's just one copy. So this is why we have kept the passing the address of a variable till the next year, because it's very tricky and you need to know what's an address and pointers and stuff like that. As for the two-dimensional array, so it will remain the same as we have seen in the array here. I just need to place the brackets and the size. Two-dimensional array, again, I should place two brackets and two dimensions, and I'll be working normally as with two-dimensional arrays. So you can see that. So let's pass to an exercise. So we need to run the following program and build the corresponding memory state. So we have main, it uses one function called P, it takes two integers, and we have two integers A and B. So let's draw the memory state. So in the main, for now I have A, it contains 0, B, it contains 0. Then I need to execute P. So I cannot continue A, I should execute P. P contains X and it contains Y. So the value of A, it will go to X, and the value of B, it will go to Y. So 0, 0. And then I would place X equal X plus 1, 0 plus 1, 1, Y, 1. And then I will print the value of X and Y. So on the screen, I print 1, 1, and then I will go to the line. Then P finishes, and then I will continue here. I will print the value of A and B. So A and B are 0, 0. That's it. So this is the output, and the function main finishes. So there should be it. Let's move to the second one. So again, we have the main function. It uses one function called anything, and we have a variable A. So A contains 2, and on the screen, I will print FA. And then I will call the function anything A. So anything, it has one variable A, so the value of A will go to X, it's equal to 2. So I will print fx 2, and then in X I should place 1000, and then I will print 1000, then anything finishes, and then I print A, which is equal to 2. So just need to pay attention that local variables are local to each function. This is the same. So let's end with just a recursive, what's about recursive functions. So as you can see, we have here multiple cats, and we have a bigger cat, smaller cat, and so on. So this is the idea. So in C, we can have a function that calls itself. So we've already seen here main can call another function, but imagine that main can call main, or a function can call the same function. So this often leads to elegant and compact code. We'll see that. And as you have seen in the memory state, so each time you call a function, there's a new allocation of its local variable. However, at the beginning, it's a bit confusing because it's very, you will be lost in how I can write a function, recursive functions. What does it mean, a separate condition, what's the base case, and stuff like that. However, it will not be responsible for it on the exam, because you will see it in large in the second year. However, while solving some of the exercises, I'll be solving it also in recursive, just to be acquainted to these stuff. So, as you know, recursion is a mathematical technique. So we've already used a lot of recursion in math. For example, we're calculating factorial, the combination, the exponentiation, even in the recursively defined sets, for example, grammar, expressions, and you will see later at the second year, like list and tree. So, however, you are very familiar with factorial and exponentiation. So let's see the example of factorial. So we know that n factorial is equal to n multiple n minus 1, multiple n minus 2, multiple 3 to 1. So we say that n is factorial. Example 3 factorial is equal to 3 to 1, 0. I will also say that 3 factorial is equal to 3 multiple 2 factorial. So if I have a function factorial, fact of 3, I can inside it call factorial of 2, and I can multiply 3 power multiple factorial of 2. So I'm calling, so to solve factorial of 3, I'm obliged to solve factorial of 2, and I have the same function, the same factorial, and we have a parameter n. And we know that by convention 0 factorial is equal to 1. So let me rewrite this correctly. So fact of 3 is equal 3 multiple factorial of 2. In order to calculate factorial of 2 is equal to 2, multiple factorial of 1. In order to calculate factorial of 1 is equal to 1 multiple factorial of 0. So there's no need to continue because this 1, I know it, it's already here. So this is it. So whenever we are doing recursion, it means that I'm always calling the same function. However, at some point, I will not call it anymore later because this is what we call a stopping condition or a base case. It means that the answer of this obviously function is very known. Like factorial of 0, everyone knows that equal to 1. However, what's the factorial of 25? Okay, it will take some much time to know it. But however, factorial of 0 is well known. So this is the idea. So I will be doing n factorial is equal n multiple n minus 1 factorial. So I just wrote the recursive version. So we have here the same two recursion versions. So let's start with these. So if the input n is equal to 0, so if I'm calculating 0 factorial, I know already the answer. There's no need to call the factorial function again. So it's equal to 1. Otherwise, so we know that there's an else here, but we can omit it. Otherwise, if n is greater than 0, I just need to calculate n multiple the factorial of n minus 1. If I'm calculating factorial of 3, I'll do n multiple factorial, so 3 multiple factorial of 2. So I can just modify, switch the instructions. So I can call n multiple factorial n minus 1 if n is greater than 1. Otherwise, I will return 1. So let's see how it will work. So this is what we call the base case or the stopping condition. Whenever we want to write a recursive function, it's very important to stop. It's very important to stop. So as a trick, I will tell you, we have the parameter, and whenever we are calling the same function, so we have the recursive call, the parameter should change. So I have here a number. So there is no, so either number should increase or decrease. So obviously if I have a factorial, I have 3 factorial, I will not calculate 4 factorial in order to find 3 factorial. So of course I'll be decrementing the input in order to reach a 0. So this is very important in recursivity. At least one of the parameter should change. Otherwise it will be an infinite loop. It will never end. So whenever we have this one, so I have factorial of 4, I'll be doing 4 multiple factorial of 3, 3 is equal 3 multiple factorial of 2, 2 multiple factorial of 1, and then 1 multiple factorial of 0. Now, when I have finished factorial of 0, I can go back and do the stuff. So as for the memory state for the recursive function, I will just do just once. However, you will see it later at the second year. So for the memory state, so I just move it here. So we'll start from main. So let's say that in main I'm calculating directly. So I just have void main and just printing printf. So I will not be using any variables, percentage %lf because we are using a float, and let's say factorial of 3. I will not make it big. So in main, I'm just calculating factorial of 3. There is no variables. So I have here factorial, and in n I have 3. So n is not equal to 0. I will be executing. I should return. It means that, okay, I need to calculate this. In order to calculate this value, I don't have the answer of factorial of 2. So here I should, the value that it returns from factorial of 2, I should multiply it by n. So I will keep that, and then I should have a factorial of n equal to 2. So the n here is different than the n there. So so I'm stuck here. In order to find 3 multiple factorial of 2, I need to find factorial of 2. So I'm here now. N is not equal to 0. So again, I should calculate factorial of n equal to 1. So if n is not equal to 0, I need to find the factorial of, so I write it here, factorial of n is 0. Now, if n equal to 0, I return 1. So now, what does it mean return 1? It means I return to the last call, not to main. So who called factorial of 0? Factorial of 1 called factorial of 0. So I return 1 to factorial of 0. And now this one finishes. What should I return now? Now I have n equal to 1, and factorial of 0, I have its answer is equal to 1. So the answer now, 1 multiple 1 is equal to 1. So I have finished factorial of 1, and the answer here is equal to 1. Now I have 2 multiple 1, and it's equal to 2, and I have finished factorial of 2, and I have returned 2 to the last call, which is factorial of 3. Now I have 3 multiple 2, which is equal to 6, and on the screen I will print 6. So I have this go and back, so what we call winding and unwinding, and you will see later at the second year, at the second semester, that we'll be using a stack. So I will not cover that because it's very advanced. So just pay attention to whenever you are writing a recursive function, make sure that one of the parameters is changed, modified. So, so the general approach is to find the stopping condition. So what we call the base case. So it's the value, it's the answer that we already know. It's very easy to compute, and we need to decompose the problem into a smaller problem. So for example, factorial of 3 is equal to 3 multiple factorial of 2. So I have that factorial of 3 is related to factorial of 2. It's a smaller problem, and we should verify that it works for any case n. So just a note, each function, each call has its own local variables. We have here multiple n's, depends on the number of the factorial. So maybe we have multiple n's. So and as you remember, the higher instances are always waiting for lower instances. So in main, I cannot find the answer unless I calculate factorial of 3. Factorial of 3, it needs factorial of 2, factorial of 1, and factorial of 0, and then we will go back. There's no jumps directly to the main. And please don't use global variables with recursive. It's very prone to mistakes, and it's not recommended. So this is it for this chapter, this last chapter. So let me just skim over the exercises that we'll be solving. So I'll be solving all the exercises that in the booklet, except the additional exercises. However, you can find all the solutions on my website. So first we will start with some numerical exercises. So we need to write a function to calculate the average. So we need to enter 2, so the parameters are 2 numbers, and then we just divide by 2 and return the value. And then we have the exponentiation, so we need to calculate x power n. So we need to do a for loop from 1 to n and just multiply x. So for this exercise, I'll be solving it again using recursivity. So as for the exercise 3, we need to write function to calculate the minimum and the maximum. So it's very easy. And for the exercise 4, it's like the function that we have already covered in the lecture. So we have x, and we need to find the value of f of x for values from 1 to 10. For exercise 5, we have a number and we need to find the digits. So we know that we just need to divide by 10, and at each time we increment the number of digits, and then we return the value. And again, I'll be solving this using recursive functions too. Exercise 6 is just factorial, so we have already solved it while doing the loops, so we'll do it in the functions, and again I'll be solving it again using recursive. Exercise 7, which is the Pascal triangles, we already solved it. However, here we'll be using the coefficient of binomial coefficient. So there's a factorial, so we'll be using the factorial function. So just we are calling the functions here. We will move to the max. So here we are calculating the maximum of an integer. So it's a very normal exercise, and we will be reviewing the abundant numbers exercises. We will move to the array. So we'll be writing a function to read array, which is the reading dimension, and to display an array, to do the summation of an array, and to calculate the average of an array. So as you know, we can write these functions recursively. I will write just one of these because it's a bit difficult to write this. So for the printing, I will be writing it recursively in 2 forms. What we'll see it later, tail recursive and non-tail recursive. So it's not important to tackle this part now, as you will see it in the second year. However, I have wrote that just for your sake of knowledge. For exercise 15, it's about prime numbers, and it's related to arrays, and we need to count the number of prime numbers. So we already know how to do that. And then we have the equality between arrays, so we need to check if it's equal and symmetric. And then we have the sorting exercises, which is to find the maximum and minimum in the array and do the insertion into a sorted array, and then to fuse this array. So we already solved that. However, we'll be doing that using functions. And then we move to the strings. We need to calculate the length. We've already done that in the lecture here. to convert to uppercase, to concatenate to string, to reverse a string, to calculate the number of words, to check whether two strings are equal, and to encrypt some functions. So those are very normal exercises. And then we move to do two-dimensional arrays, which is to reading in the matrix, write a matrix, summation, the addition, and the multiplication with the real and matrices. At the end, we have in the booklet two recursive exercises too, which is the Egyptian multiplication and the Fibonacci sequence. So we'll be solving it using recursivity. So this is it for this semester and this chapter, the I1101. So at the next year, and for those who will continue the computer science, you will be doing the I2204, which is the continuation, and it's a more advanced part of this course. So your instructor will be Dr. Siba Haidar. And as for the content for the next year, the first semester, you will review also the recursion, and you will go deeper into recursion, into the memory state, and to see what's tail recursive and non-tail recursive. And then you will see pointers. So pointers are very useful in order, like for example in function, you use the passing by value. You are copying the value. You can use the original variables in main and modify their content. And then you have the structure. So it's like you have arrays and strings and integer and float at the same type. So you have a type called struct, and you can place anything you want. You can define, for example, a plane, a virus, a home, and you have many variables inside the stuff, and you can manipulate it and copy it and use it as if normal variables. And then you have a dynamic memory allocation, which is, for example, you have dealt in this part with static arrays. So arrays have a fixed size, so we can shrink, make it larger, or modify the number of elements in this array, and so on. So there's multiple ideas on how you can do dynamic memory allocation. And then you move to what's called a linked list, which is a more efficient way to deal with arrays. So there's multiple types of linked lists. You have a simply linked list, circular linked list, double linked list, and so on, and any combination of these three lists. And at the end, you will see a file. So we can open a file on a PC, how we can write file. You have text file, binary files, and stuff like that. As to end, so I'm just wishing you a good luck. And the most important, as I have told you, so you'll all have the same exam, you will all have the same lectures and courses. Just think about the box and try to work on yourself. And thanks for watching me all this semester, and stay safe.